You should have done labour.
Unless you will sell you with like monetary.
I think this has to be the small stack though. This has to be the small
No,
stack.
it was bigger.
To be fair, it does feel like you've genuinely pursued lecture. Like I feel like we
Yeah. But now we're saying, I don't listen. I don't ask questions. I just tune him out.
yeah, that's been my strategy for most of the year. It's worked so far.
The thing is that it's actually a lot of way to write it.
Yeah, but if you write it out differently, thousands of words. It's like, as in like, here's the full word rather than just words. And then
Yeah, but if you listen, you can understand the conceptual jump that he made in those. It's relatively to Lebanon. Yep. Oh, the US has finally told its citizens to leave Gaza. It's a threat from everyone.
finally,
Yeah. As if Gaza was a safe place to be.
my dad told me a couple days ago, not days, a couple months ago, that I should vote for one in Dubai. And given the current circumstances, I don't think that's
That would be ideal, right?
I think the UK is looking to like bring back something like 70,000.
That's a lot of
expats, yeah. From Dubai. How many of them do you think are like millionaires? Are they going to be greeted with an HMRC letter when they get back?
I think they're just thinking about tax.
Exactly. But think about it. If all these tax havens are no longer safe places to stay, we can do a wealth tax. We can do a wealth tax every. Okay, where are you going to run? Are you going to Dubai? No. Don't do that. Get hit with a missile.
But Luxembourg.
Oh, fuck Luxembourg.
So much Luxembourg.
I just don't like tax havens. I'm literally so Let's tax people. Let's just tax them. I find it so funny that like people much of large all of you tax the rich that all leave the country, and then he delivers like speeches for company called Nomad Capitalists or something like that, which is a company that essentially tells millionaires and billionaires how to move their wealth around the world so they can avoid tax. As if he's not the problem.
I feel like these are much shorter and shorter.
Yeah, I agree.
I think he probably just sleeps, like, takes his habits, and then just wakes up and runs his life. I don't know.
He doesn't exist until he walks through the door. I guess when he's like, it's like,
That's kind of just true.
Like phases into existence.
right. Literally, yeah. He's like loaded in as an asset that walks through. Like a T-post there.
I hope he listens back to budget politics. Should we just start writing the notes?
We could check in code. Check in.
Sorry.
Lead.
Hello.
20374. Okay. Okay, sorry again, but we should be fine in terms of what we need. Questions before we start? Were you all right with your question the last time regarding the numbers?
I was
quite remember.
What was that one?
Right, so here's the story. Either, so not doing everything again, you had beta gamma, right? If there's a strict inequality, then that argument is more or less direct. It shows you that the lambdas will be strictly decreasing for both agents, and therefore the equality that must hold when the amount of money being carried is positive, which has to be the case for some agent at each date, that will be. So that's done right there. If beta equals gamma, then lambda takes the same value forever. Now lambda cannot be zero, which was your question. Lambda cannot be zero because of the first order condition on consumption of the consumption good. Okay, that was beta t u prime is less than or equal to lambda it pt. Right? So if lambda it were to be zero, necessarily u prime would have to be zero. U prime cannot be zero unless consumption is infinite. It's really increasing concave function. So that can argument between last week. So lambda can never be zero. And therefore, if lambda is not zero, and it's a constant for all the agents, right? Then the limiting value of lambda will not be equal to zero, which is the determinant transversality condition that you need for holding money. Someone has to hold money even with it. That's the argument. So again, there are even in the notes when you read it, you might feel that there are things that I haven't written down, which follow, which were discussed in class. You should make sure that that note is complete. But as I said, you should not expect to get any of these standard proofs, so to speak, on the exam. That's not the purpose. As purpose is that there won't be stuff that is demanding. That's a different matter. Okay? But I'm not going to ask you prove the first welfare theorem or prove something like this. Any other things. Okay. So what we had, in some sense, in we saw yesterday, and we continue with that. So when xit is strictly positive for both agents at each t, always write this, and sometimes I will. Then we saw yesterday that the following condition will hold. This is directly from the first order condition. So we don't need the ui here, which is prime, the utility functions are the same. xi t plus 1 xit equals pt plus 1 lambda t plus 1. Okay? That will hold, and in addition, we had lambda it plus lambda t plus 1 is going to equal 0. Equals 0 if. Okay, this is what we had. So now what we were saying yesterday is, well, what we showed yesterday were two things. One, in any Pareto optimal allocation in such an economy, consumption must be constant for both agents. This we had shown. Okay, I shouldn't say we had shown, we had claimed. You need to show it on the problem set. Okay, that was the claim. And there it is important that the aggregate endowment is constant. You can see that. That's the reason it's on the problem set. So check. And you understand a bit on variations on that. So if consumption is constant and therefore the amount of money, the money supply is constant, so the amount of money that you will need in order to carry out trades will be constant, and therefore prices will also have to be constant. So if there were to be an equilibrium which is Pareto optimal, not only consumption but prices would also be constant. Okay? And yesterday we saw that that's not possible. That leads to a contradiction in terms of the first order condition. This is what we saw. But what we have on the board is still correct. Okay? Yesterday we dealt with necessary conditions, today we're going to deal with sufficient first order conditions. The first order conditions are still the same. So now we want to ask, what is a simple equilibrium? What would be a simple equilibrium? So consider that prices are actually constant. Okay, suppose prices are constant. You might start thinking, how can that be? Prices are constant and yet consumption won't be constant. Something's going on. Actually, it should be all right. So prices are constant, and therefore that condition there now becomes, this is indicating how you will find an equilibrium. Over there you get okay, and from that one you know that that is less than or equal to 1 followed. So in some sense we've reduced what we need to look for to essentially that condition at every date for both agents. And the allocation should be feasible. Is it okay? That's what we're doing. Very good. So then, as I explained yesterday, the idea would be to say, look, at dates at which an agent is rich, and there's one agent who's rich, the other's poor at that date. At dates at which the agent is rich, he will buy money from the other agent. Carry it over to the next period. When he's poor, spend the money to buy the good. Spend all of it. There's no reason for him to carry any excess. Why? Because the following period he knows for sure that he'll be rich again. Is that okay? So the structure of the equilibrium that we are hypothesizing is one in which at even dates, Mr. A is rich and Mr. A will sell the money that he has at even dates. Mr. B will buy the money at even dates. And Mr. A will buy the money at odd dates, and so on. What we need to specify first, so this is the, in some sense, it's not easy, but at least to say it, once you understood it, it's the easy thing. What we need to do, of course, is specify what is the consumption value, which is also not too difficult to do, and from then on, to make sure that we satisfy all the first order conditions. So we have a feasible allocation, where all the first order conditions are satisfied, the utility function should be concave by an appropriate extension of the Kuhn-Tucker theorem, which we are not doing here. We can use the first order conditions to say that they are sufficient. But we need to check all of them. Is it okay? That's what we need to do here. So, so what do we get from here? One bit that I did not write. We know that it's less than or equal to 0, but it's also with equality. MIT is positive. Hence, when MIT is positive, you get beta q prime xi t plus 1. That's I t plus 1 must be equal to q prime xit okay? So the date at which individual I is carrying money That's the date at which the first order condition takes that. Is it okay? Make sense? Yes, no, maybe, please, let's be clear. You were not in class yesterday, but hopefully you're able to follow. If not, we need to ask.
Yeah, I think it, yeah.
Just make sure. You will have exercises, etc. Not too many, just one exercise. I'll clarify things for you. Is that all right? Yeah. So we brought it down to that condition. Now it's pretty clean so far. So now we know that in our example economy, the aggregate endowment is 1. The same method applies even if the endowment is some other number. What matters is that the total endowment at each period is the same. That's the important thing. Right? So the rest you need to work up yourselves. So solve for x star such that what is true? Well, beta on this side we will get u prime of x star. Okay, so this is consumption when rich. Is it okay? What will you get here? Well, u prime, what should you get inside? Next period, I'm going to be poor. So the other chap will be rich. So how much will I consume? Well, the total endowment is 1. The other chap gets x star, so I get 1 minus x star. Is it okay? Now, obviously, since beta is in 0, 1, and u is strictly concave, it should come as no surprise that x star will exceed a half. Right? For that equation to hold, since u prime, yeah, C here. U of C, looks something like that. Increasing. Okay. The marginal utility keeps dropping. Right. Beta is strictly less than 1. If that equation is to hold, x star has to be greater than a half. So in periods in which I'm rich, I consume more than when I'm poor, which makes sense. But you don't want to do it the other way around. Okay? You have to be able to justify that. That's how you justify it. Is that okay? Yeah? Think about what happens if you drop the beta here, and that's one way of thinking. Anyway. So x star exceeds a half. So what's our proposed solution? Proposed equilibrium, so x so when I look at A's consumption at even dates, I'm going to say they're all the same. And they're all going to be equal to this common value, x star. So the x star at the other end, but then you have these dot dot dots. That might not be very nice to write. And at odd dates, it's going to be 1 minus x star will be A's consumption. Okay. And the reverse for B by feasibility. But feasibility is not the only thing. You also need to make sure the first order conditions hold, which actually we are doing by symmetry. Sorry, this should be, yeah, sorry. What about prices? price? Price should be such that the amount of money that you have allows you to carry out your trade. Right? How much are you trading? Look at the rich guy. 1 unit in endowment, X star is what he consumes, the rest is what he trades. So that's your equilibrium price. Is that okay?
Can you explain that?
Yeah.
A little bit.
Yeah. Yeah. So you're using money to carry out your trade. Okay? Think of him as the person who's buying the money now. The amount of money available with the other chap is M units. Right? What's the price of the good? It's some fixed value P star, P bar star. That times the amount that you are selling. Right? X star is your own consumption when you're rich. So 1 minus X star is what you're selling. That times the price is what you will pick up in exchange for the goods that you give him, which will be the money. Right? You go to the store, you give a fiver, right? You buy something for £2, so you get 1.5 units. So the price times the number of units that you're buying will be equal to the money that you had over. Yeah. Over here, that's the amount of goods that he's selling. So this is from the view of the person who's providing the service to you.
Oh, yeah.
So it's symmetric. So consumption is feasible. It adds up to the aggregate quantity, which our example economy is 1. We figured out prices, right? The money market clears, since that condition essentially guarantees that your budget constraints will hold. All of that is taken care of. Okay? We made sure that our X star satisfies the condition there, from where we can argue that the rest of the first order condition is satisfied. So I'm not going to do that in any detail. Okay? Observe from here that, okay, so at dates at which I buy money, so those are the dates at which I'm rich, at those dates this condition holds, right, from there, that condition holds. So at dates at which I'm buying money, since that condition holds, this one holds with equality, so that condition holds with equality, so that's not a problem. And at dates at which I'm selling money, so let's finish talking through it. Let me write it out with 2 cases here. So when buying money, T is some date at which I is buying money, right? Beta U prime 1 minus X star divided by U prime X star equals 1. Okay? So beta U prime Xi T plus 1 over U prime Xi T equals 1. So star holds. This one star. Star. When selling money at T, what will we get? We will get beta U prime X star divided by U prime 1 minus X star. Okay. Whether that's equal to or less than 1 is something that I'll write in a moment. What does that correspond to? So it's U prime, again, Xi T plus 1 divided by Xi T. So we're always thinking about what is your consumption at date T and what is your consumption at T plus 1. Okay, in this case, at date T, your consumption is 1 minus X star, and at date T plus 1, your consumption is X star. x star exceeds a half. So since beta is less than 1, you can check for yourselves or ask me if it's not clear. That quantity is strictly less than 1. Work it out with that figure. Okay? U prime x star takes a certain value, multiplied by beta, which is less than 1. That value will be smaller. Sorry, that value will be smaller. And u prime 1 minus x star will take a larger value than u prime x star. X star is larger than half. Beta is between 0 and 1. Your utility function is concave. X star exceeds half your endowment. Therefore, even if you ignore the beta, that ratio is less than 1. You multiply it by beta, it continues to be less than 1. Okay, and therefore, I know that here it's less than 1, and so star is again. Star requires that that condition is always less than or equal to 1. There's more to be done, but we're at least on the correct track. Messi. Okay.
They'd sell all their money.
Sorry?
And they'd sell all their money.
Yeah. There's no reason for them to do this. We'll get to that in a minute as to why. But it should be clear. There is no reason for you. You're carrying money in order to carry out a trade. Why would you carry more money? You would do that if you were uncertain about what will happen tomorrow. If you were not sure that you were going to be rich tomorrow, then of course you'd like to keep some in your wallet. If you're certain that tomorrow you will get your tomato, you might ask, are people actually certain? The answer is all right. That's in the realm of reality. That's slightly outside this model. And I'll talk about why there's an issue. I mentioned that yesterday. We'll get back to that. But let's be clear about this. Is it okay? So what remains is to specify, remember, sufficient conditions for a maximizer say that you have to find values of your variables, which means the choice variables and your multipliers, such that all your first order conditions hold. And your problem is one which is a convex problem, which is the utility function here is pretty concave, your budget sets are given by straight lines. Okay? In those conditions, you can say that the first order conditions are sufficient. So we need to specify the lambda. Okay? Specify. Again, following the notes and doing this only for one agent. You can do it for the other agent. Lambda AT is defined to be, so they have to satisfy all our first order conditions. So done this way, they will. That's the price. Okay, the inverse of the price. So the price times lambda equals beta t u prime x at. This is what you want from the first order condition for the consumption good, which I haven't written here. That's where we got this equation from. Each of those, the numerators and the denominators, came from there. Okay, for all t. That does the job. Lambda at and similarly lambda bt. So you use the corresponding values, x star or 1 minus x star, depending upon where you are, which date. That give you your lambdas, and you can see your lambdas go to 0. Okay? These two terms, well, this one is a constant. This one fluctuates between two values. This one goes to 0. So your lambdas will go to 0. So your limiting value for your lambda, which was your transversality condition, what happens to lambda t as t goes to infinity, that is required to go to 0 for the agent who's carrying money. That's also set. Everything is set. Questions on what we've done? You like what you see? Interesting. Yeah.
So that's true for all values of t, not just.
This is a definition.
Yeah.
I'm defining lambda to be what I have on the right hand side, since
Yeah.
everything on the right hand side has been specified. Correct? That will give me a set of lambdas which will satisfy, together with the values of x that I've chosen, they will satisfy all the first order conditions. So my first order conditions become sufficient. Sorry?
And the limit they go to 0.
Yes.
But just the limit, not always.
No, it cannot. This is what I said right at the beginning of the class regarding your question from yesterday. Lambdas can never be 0 at any finite t.
Yeah.
The reason is, if you, the first order, so let me write that on the board. So the first order condition that we had for x, okay, was beta t u prime xi a t. It's less than or equal to, but it's the same argument holds also for the inequality, but it's just easier to write it when you have inequality, right? So if lambda it were to be 0 at any finite date, and your first order condition holds, the left hand side has to be 0, right? Beta t cannot be 0 at any finite t. U prime xit would have to be 0. When is u prime xit equal to 0? Well, if at all, when consumption is infinite, but that is incompatible with equilibrium. There's stuff in economics written by very important people where they study just the consumer's problem, and they run into these sorts of issues, and they say, okay, this can happen, that. It cannot happen in equilibrium, unless you have a growing economy. You have growing economy, that's not the world we're talking about. In the world that we are talking about, it cannot be that your marginal utility blows up. It cannot happen. You have, why? Because equilibrium tells you it cannot happen. Equilibrium can be very powerful. Feasibility. These are bits and pieces that seem like, it's obvious and trivial. Yeah, it's obvious and trivial, all that's true. But they have implications. That's the important. They tie things down. This is what makes things interesting and difficult. You should make sure that everything fits in. Is it okay? So that's a simple, it's the simplest kind of equilibrium you can find in that economy. As we've shown, you cannot have an equilibrium with constant consumption. What's the next best? An equilibrium in which consumption fluctuates between two values. However, that means it's inefficient. It cannot be efficient. Correct? That was the other thing that we claimed yesterday, and that you have to show in problem set 4. The first problem set 4 will require you to do that. Okay, I showed you how to set up the problem, which you missed, but you can have a check with your friends. They might be able to tell you. Right? Okay? So now, what we saw in Gramo-Yunus was, well, okay, inefficient. Think about Friedman. What do? Remove money. Remove money. Over here it's a bit more complicated because you have consumption at 2 points, but the more interesting question now becomes, and this was what motivated Bewley. Okay? The question is, all right, in this really almost, you could smirk and say, how can you believe that you will know with certainty that for the rest of your life, you will always get one tomato on every even day? It doesn't make sense. I agree with you, it doesn't make sense. It doesn't make sense. So think of a very simple economy in which again you have just one good, right? And whether you get a tomato or not is probabilistic. It's a very simple two-state Markov process. Yeah? If it's sunny, you get a tomato. If it's raining, you don't get a tomato. It affects your endowment. All right. And your endowment need not be as extreme as 0, 1. So long as it's not equal in the two states, that's good enough. So this was the degenerate case, where it's a Markov process. You know what a Markov process is, but with probability 1, you're in one state, and with probability 1, you're in the other state. Probability 1 in the sense, depending on where you are today, tomorrow you go to the other state with probability 1, and it's a Markov transition matrix of 0 and 1 as elements. What if you actually do have risk? Well, now think about it. And as I said yesterday in class, that is the problem that Bewley set up. It's conceptually and mathematically, it's a much more difficult problem to solve. Not something that's even taught in graduate school yet. It's got a very good place, unless you have someone who really understands this thing inside out, they're not going to try to teach it. They talk about it, they won't teach it. Okay? So, but the idea can actually be explained quite easily, hopefully. I'll try. Okay? I should point out that when Bewley published his work, there was a mistake. And as he says, he realized there was a mistake, and there was another very well-known economist Martin Helmich, who also wrote to him saying that there's a mistake. And the correction to that paper was published as a full paper in what is considered to be the best journal in economics, which is Econometric. Okay, the correction that Bewley wrote became another paper in Econometrics. So what is the result? So the result is the following. So if you think about it the following way. Suppose I compensate you for holding money. Again, I'm not going to ask you to write an essay on this. It's just so that you can be satisfied that what you've seen on the board is not what, this is not supposed to be, brilliant work. The brilliant work is actually the model of this, of which this is a very special case. Okay? So suppose I compensate you for holding money. The cost of holding money is your discounting. Right? If you buy it today, you have to wait and spend it tomorrow. So discount is basically the problem. That's why it's costly. That's why you try and cut back on how much you hold. So I pay you interest to make sure that you don't bear that cost. Now, you know that you're not certain as to whether or not you will get your tomato tomorrow. Okay? So you'd like to carry a little bit of extra money. Make sense? You're not going to spend all of it today. But the nature of a Markov process is such that there is also some positive probability that you won't get your tomato not just the following day, but even the day after. So there is positive probability that you will keep not getting your tomato for as long as you'd like to believe. The probability, and here's, those of you who are doing econometrics, think about this carefully, very carefully. The probability that you never receive your tomato is a zero probability event. That happens with zero probability. But the probability that you don't receive your tomato for a finite length, and that length could be any finite number, is positive. Even if you don't do econometrics, you should be able to intuitively grasp what I'm saying. So if there is uncertainty, if there is risk, you know the probabilities with which you will or will not get your tomato. But you have to account for the fact that with positive probability, you might not receive your tomato for how long? For as long as you wish to wait. Not forever, but as long as you wish to wait. Fix a finite date, it happens with positive probability. Therefore, if the cost to carrying money is zero, your money demand will basically blow up. You will demand more and more. Why? Because you're insuring, and the cost of insurance is zero. Is it okay? So what Bewley proved is that if you have a common rate of discount and you provide interest at that rate of discount, there is no stationary equilibrium. He said what Friedman is claiming collapses effectively if you actually try to think about doing it correctly in an economy with risk. In other words, going back to what Frank Hahn always said, if you're using money in the economy, there has to be a good reason for it. The equilibrium will be inefficient, and if you want to get rid of the inefficiency, you're basically killing the reason for holding money. So in this economy, once you have the proper Bewley economy that you look at, if you want a stationary equilibrium, you will continue to always get inefficiency. In Gromov units, you could fix it. In the particular case where all discount factors were the same, and that was the common rate of interest, you could fix the problem by paying that rate of interest. But here, if you try to do that, the equilibrium blows up. It's no longer a stationary equilibrium. Whether it's a non-stationary equilibrium or not, it's a separate matter. I don't know if there's a result on that. But there is no stationary equilibrium if you try to do it here. So every stationary equilibrium here is inefficient. You cannot cure the problem. Is that okay? So I'm asking you to believe a bunch of stuff here clearly. But hopefully, I've been able to get across to you what are the issues. When is it that actually things can be fixed? Things can be fixed, but those are very special cases. Particularly, you need an economy that's deterministic. Is that okay? Questions? Anything you want to ask? I don't think I have anything more to say on this material. Yeah.
If that was a big critique of Friedman,
Sorry?
if that was a critique of Friedman
Yes.
where you said that you can't use his rules to get out of
Yes.
that situation,
Yes.
did Friedman come back and defend his original thesis?
No. So two different things. Friedman was too old by then. Not that old. He won the Nobel Prize in 76, if I'm not mistaken, and Beauty wrote his stuff in the late 70s. Beauty's work was circulated around 78.
He would have been 60. I think Friedman was born in 1910.
Yeah, so he died much later.
Right,
Yeah, it's not that he was not around with us. So as I said, there are two answers. One, and I know this from my supervisor, whose supervisor got his PhD at Chicago and was derided by Friedman because he used to do mathematical economics. Friedman was a very good debater, and not as all debaters, but as some debaters, he would be a sort of slippery person. He would say something in response to something that he'd said, then he'd start saying something else. So it was always very difficult to pin him down. So that's the informal stuff. The formal stuff would be that it's not that this stuff has not been well accepted by those who think about these things seriously. Okay? But, a few more, it's a good question, so a few more answers here. The second name that I mentioned was Martin Helvich. He was the person who also wrote Bewley saying that there's a mistake in his paper. Martin Helvich is a very well-known theorist, very well-known. German. He has a lot of work in many areas, but his initial work was also on money, but then he stopped working on money for many years. He worked in asymmetric information and other things. It's very important work in insurance. And Martin Helvich, when he was working on money in the early 90s, I know this from other people, that there were very senior macroeconomists at Harvard saying that, why do we need to learn about money from Martin Helvich? So there is a problem in economics that there's a group of people who sort of think that it's, we understand how macroeconomics works. Why do we need to do this carefully and formally? Now they are right that there is a lot as in any subject, even in mathematical economics, there's a lot of stuff that you would say, don't bother with this. What's the point of doing this? This is true. But there is other stuff that actually you need to do it carefully. So even amongst people who did not necessarily follow Friedman in his ideology, there's always been a reluctance to think carefully about these things, because thinking carefully about these things takes years of work. As I mentioned yesterday, Bewley, I think I did, Bewley was a student of history as an undergraduate, as was Bob Lucas. Bob Lucas also studied history, I think at Chicago, as an undergraduate. Bewley studied history at Cornell. And then he got a PhD in economics and a PhD in maths at Berkeley.
Yeah, he said that.
Yeah. So, very serious people, very nice person, but very serious people in terms of how they approach the subject, regardless of what other people thought. And there's other stuff that he did in the 70s, which was very well received, but later he said that I wasted my time. I shouldn't have done that stuff. So,
What stuff is that?
since we have a few minutes. Okay, so you remember I explained the notion of Pareto optimality in class with the definition. Now there is a stronger notion which in economics is called the core. I don't know whether you've talked what the core is, but the core is the following idea. When you look at Pareto optimality, you put everybody in a room and you say, all right, you can redistribute your resources amongst yourselves. Okay? You have a Pareto optimal allocation when nobody can come up with an alternative where everyone is at least as well off and somebody is 50 better. Now suppose I say, all right, you are also allowed to leave the room in a group. You can form your own group. Okay? And that group can say, are we able to do better or not? With what we have as our resources. So every group is also allowed to do the same thing. You apply the Pareto optimality test, but also to each group and each individual. Okay? So remember, with the Pareto optimal allocation, one of the things that I said, and you would know this, is you need not be happy with what you get. Everything on the contract curve is Pareto optimal. Now clearly, if you could say, look, I'm walking out, I don't like this, right? You could do that. You would want to make sure that what you are able to consume on your own is guaranteed to you. Pareto planning does not guarantee that. Right? So if you impose the further requirement that not only you as an individual and the entire group, but every group also has the right to walk out. The allocations that remain are called core allocations. And the notion of the core, not in this name, if I'm not mistaken, is due to Gale, but Gillies actually, Gillies and Gale. But the notion of the core goes back to Edgeworth. So there's a book called Mathematical Psychics. It's not a very long book. Edgeworth was British, very well known in his time, and he tried to set up a solution to the exchange problem through differential equations, things like that. It's strange, I think, was maths and physics. Mathematical Psychics is a beautiful book to read. Okay, he gave a completely different foundation because he said that, look, what you actually see in trade is people are looking for core allocation. And he was right. It was only in the 50s that people realized that this notion of a core had been discovered by, or invented if you like, by Edgeworth, but there were people working in game theory at Princeton who came up with the notion of core on their own in a different concept, in terms of things called cooperative games. And then in the 60s and 70s, there was work to relate that to the competitive equilibrium. It was very important work by someone called Aumann, who won the Nobel Prize in game theory, who showed that if you have an economy with, technically it's what's called a continuum of agents. So every agent on the interval, every point on the interval represents an agent. In such an economy, the competitive equilibrium and the core allocations are exactly the same. So then the question was, if you take economies in which you have more and more agents, is it the case that the core allocation approaches instead of competitive equilibrium? So there was very important work on that by de Breuil-Scarf in the 60s. Bewley was a student of de Breul's, and Bewley's thesis was on a different problem, but in the early 70s, he worked with core convergence. Bewley's thesis was actually on proving equilibrium in economies with an infinite number of goods. The sorts of things that we're looking at, these are very special cases of what Bewley actually worked on for his doctoral thesis. It's extremely important work. Again, all of macro now is done with an infinite horizon, etc. Except that most people who do macro are aware of much of this literature, but they don't invest in trying to make sure that they follow it. That's important. It's also very popular to do things with fixed prices, etc. Personally, I have nothing against fixed prices. It's just I find we don't have a model which gives you fixed prices. This is why you don't see any fixed prices in that I do. I'm still waiting for a good model of price objectivity. I don't think simply assuming it is a good idea. When Keynes did it, it actually might have made some sense because he thought of unions and said, nowadays unions and bargaining in that form don't really prevent price flexibility. If you look at UK unemployment rates over the last 30 years, you really have had high unemployment. So to argue that there's a recession and unemployment is a huge problem, whether it be because of appropriate central bank policies or not, is a separate matter. But you don't really see it. So there's foundational work in the sorts of models that we need, and the sorts of models that you're seeing here, but the foundational work in terms of the equilibrium theory is actually very technically very delicate. So I try and teach what I think, with some effort on your part, you're able to follow and appreciate. But this material is I don't think it's taught anywhere. I'm not aware. Okay. Not in this one. Not just one particular model, but overall what we do. Questions? Anything else you want to ask? So this brings us to, you can ask questions while I continue. So this brings us to a close to basically the first half. If I'm not mistaken, we don't have a lecture next Monday. So we'll get done with problem solving sessions next week, and then The following week, you will have the seminar, and we'll start on the second half. So on the second half, we will spend quite a few lectures on something called the overlapping generations model. It's a very different way of doing things.
Repeat that.
Overlapping generations model. Yeah? So the key point over here is, here you have two agents who live forever. So their optimization problems are a bit hairy. In the overlapping generations model, each agent will live for 2 periods. So their problem is as simple as you can think of. And yet the economy will behave in a strange way. As you can see. Sorry? It will be without production. It will be all money. Yeah.
With overlapping generations, are we assuming each generation is related to the previous stage?
Yes.
Yeah.
Related in, not in terms of altruism. Related through the market.
Oh.
But we know altruism. You can do it with altruism, but the key properties that I will be interested in focusing on will come out without altruism. See, my focus here, as you can see, is it efficient? What's the role of money? Can we fix it? Do you have strange outcomes? Things like that. The strange outcomes bit we will not do, because that will take us out of the syllabus. But if we have time, I can talk a little bit about that. We'll talk about Lucas's Nobel Prize winning work, created rational expectations, etc. Not in any detail, but there will be a lecture dedicated to that. And then we will do 2 topics on that. Thank you.
Thank you for sending me the
Okay.
problems.
Sorry?
Thank you for sending us the solutions.
Well, it was posted. I was meant to, I just got caught up. In the same way as I'm meant to send around more details to everybody to say that you're the module where I don't have time to do it. But yeah, in general, the problem solution is posted.
Yeah.
Okay. Okay, see you. Yeah.
Cheers.
Okay, bye.
Thank you.
All right.